Okay, another one of the derivatives. So here, simplifying the derivative of a quotient. Here, I'm hoping that you'll see, obviously, that we have the quotient rule happening, but I'm also hoping that you might recognize that right here, we're going to have the use, we're going to need to use the chain rule. So I'm just going to start with my derivative. I'm going to start gathering my list of stuff. So I'm going to say that f of x is equal to x, f prime at x is equal to 1. Say that g of x, as I'm building my quotient rule here, is equal to x squared plus 4 to the 1/3 power. And then g prime at x will equal the derivative of the outside. So the derivative of the outside, I'm looking at this piece right here right now, this 1/3 right here. So is equal to 1/3, wow, I said 1/3 and wrote a half. 1/3, the crap on the inside, to the negative 2/3 power times g prime at x, right? So what's on the inside is just this x squared plus 4. Just put that back. Now I want to take the derivative of that inside to finish my chain rule out. And the derivative of x squared plus 4 is just 2x, isn't it? So I'm going to keep working. I'm going to try to clean this up a little bit more and say that g prime at x is equal to 2x over 3x squared plus 4 to the positive 2/3 power, right? Because I dropped this out into the denominator. Now, I'm going to go ahead and start building this quotient rule problem. And the quotient rule problem says that we have x squared plus 4, which is g of x, isn't it? Times f prime at x, which is just 1, minus f of x, which is x, times the derivative 2x over 3x squared plus 4 quantity to the 2/3 power all over g of x squared. So we have x squared plus 4 to the 1/3, so times that by 2 because we're going to square that to the 2/3 power. Wow. So what do I want to do here? Okay, I know what I want to do. So I'm going to try to set myself up for success here. I'm going to multiply. I'm looking for a common denominator in my numerator, if you will. So I have this thing down here. This whole mess here. So if you don't mind, I'm going to multiply this whole thing times that value. So I'm going to multiply this times 3x squared plus 4 to the 2/3 power over 3 times x squared plus 4 to the 2/3 power. And if you look at it, that will give me this. That will give me this. This times this. X squared plus 4 to the 2/3 times x squared plus 4 to the 1/3 is just x squared plus 4, isn't it? So we have 3 times x squared plus 4 times 1 is just that. Is negative, and then negative x times 2x is negative 2x squared, isn't it? All over 3 times x squared plus 4 to the 2/3 power all over x squared plus 4 to the 2/3 power. And I'm going to look at this way, if you don't mind. I'm going to look at this as a complex fraction. If you remember the rules of complex fractions, then this comes up as its reciprocal, which would mean 1 over, and it would be this thing right here, this x squared plus 4 to the 2/3, x squared plus 4 to the 2/3 power. That gets rid of all that crap. This problem is a lot, isn't it? It takes a lot to think your way through all this algebra. It's really a pain. And if you're wondering, I'm doing this without any notes, so I hope I hope I'm doing it right. Now I'm going to go ahead and distribute this piece through to here and here. Make sure I distribute completely. And that would give us, wouldn't it? It would give us 3x squared plus 12 minus 2x squared all over. And if I multiply 3 times that, I get 3. But when I multiply x squared plus 4 to the 2/3 times x squared plus 4 to the 2/3, I get x squared plus 4 to the 4/3, right? Am I doing okay? I'm going to simplify again. I'm going to keep simplifying this out. Somebody asked me earlier, like, when can you cross stuff out? These are add-ins, so we can't, unless we factor out some term, and these three numbers are relatively prime. So I'm going to go ahead and add like terms. I'm going to get 3x squared minus 2x is x squared plus 12 all over 3 times x squared plus 4 to the 4/3 power. Man, that worked out okay. And that gives us our f prime at x, final solution. That was a ton of algebra, and if you get anything from this at all, is that you have to stay really sharp on your algebra. On the AP test, what they're normally going to do is they're going to simplify it out as far as they can. Even if they could expand, they're not necessarily going to expand it, but they're going to simplify it out the best that they can. So hopefully this was helpful. Thanks for watching. If you haven't already subscribed, please subscribe.